Welcome to lesson 5.3, the triangle midsegment theorem. Today's objective is for students to be able to apply the midsegment theorem to find the side lengths of triangles. So to get into today's lesson, we should probably know what a triangle midsegment is. And what that is a midsegment is a line that connects two midpoints of the sides of a triangle, and that is called the midsegment. Alright? So for example, in this case, we know that D is the midpoint of AB because AD is congruent to DB, so D must be in the middle. And we also know F is the midpoint of BC because BF is congruent to FC, so F must be right in the middle. And that means that DF, if I connect these two midpoints, would be the midsegment. So the line that connects the two midpoints is the midsegment. Now there's two facts that we know about the midsegment, and this is the midsegment theorem. One is that the midsegment is parallel to the base. So in this case, we know that DF is our midsegment, and that's parallel to our base, which is AC. Okay? So DF is parallel to AC because DF is the midsegment. We also know the midsegment is half the length of the base. So in this case, we would know that DF is equal to 1/2 the length of our base, which is AC. So for example, if AC was equal to 10, the midsegment would be half of that and be 5. Alright, let's see if we can use this theorem to solve some problems. So in the first one, in triangle TCB, we know CT is equal to 4, and AB is equal to 12, and TU is the midsegment. Alright, so we're given a lot of information here, so we should probably fill it in. CA, which goes right over here, that's equal to 4. And AB, oh sorry, that's CT. CT is equal to 4. AB is equal to 12. And TU is our midsegment. Alright, TU is our midsegment. And how are we going to use that information? Well, if that's the midsegment, that means T and U are the midpoints. And that means CT is congruent to TA. And CU is congruent to UB. Remember, because this is our midpoint. Alright, that's all very useful information. Now let's start filling out our questions here. Well, what is parallel to what? Well, we know that TU is parallel to the base. TU is our midsegment, and that's parallel to our base, which is AB. Alright, TU and AB are parallel. Now we want to know what TU is equal to. Well, we know that our midsegment is equal to half our base. So if our base is 12, TU will just be half of that. So we'll just take 12 divided by 2 and we get 6. TU is equal to 6. And now we want to know what AT is. Well, once again, if T is the midpoint, we know that line segment AT is congruent to TC. So AT must be 4. Beautiful. Alright, let's try another example. In triangle RBP, we know OA is equal to 8, RB is equal to 20, and O is the midpoint of RB. Midsegment. Nope, O is the midpoint of RB. And A is the midpoint of RP. Well, let's fill that information in. OA is equal to 8, so that would be this segment right here. OA is equal to 8. RB, which is right here, is equal to 20. We know O is the midpoint of RB, so since O is the midpoint, we can mark these congruent, RO and OB. And we know A is the midpoint of RP, so I know that RA is congruent to RP, because A is the midpoint. Now what can I do with this information? Well, first, what's parallel to what? Well, if OA is our midsegment, we know that's parallel to the base, and that's right here. Okay? So OA is parallel to BP. Now we also want to know the length of PB. PB. Well, we know our midsegment's 8, right? So if our midsegment's 8, we know BP is going to have to be twice that length. So we would just do 2 times 8 because the base is twice the length of the midsegment, and that would give us 16. And just in case that doesn't make sense, what's half of 16? 8. Oh, you see that magic? That changed to RO. That's what I meant to say. So we're trying to look for RO. So RO, which is this part of the line segment. Well, if we know the whole thing is 20, and these are both halves of that, we know that RO would be 10. Okay, let's get into some like algebra solving using the midsegment theorem. Well, DE is the midsegment of our triangle over here, okay? Is our midsegment of our triangle. D is our midsegment. Now, how do we know that? Well, we knew that because D is the midpoint of CA, and we knew that because we have our congruency marks here. AD is congruent to DC, so I know D must be in the middle. And I know CE, all right, is congruent to EB. So E must be in the middle. So because these two are our midpoints, we know that DE, if we connect those, that would be our midsegment. So how do we know? Because D and E are the midpoints of the sides. Midpoints of the sides. Now the question is, we want to find the value of x. How do we do that? And this is what you can do. We know that AB is twice the length of DE. Okay? AB is twice the length because DE is half of this. Another way to say that is AB is twice the length of DE. So to set up our equation so we could solve for x, we would say 2 times DE, all right, 2 times the midsegment is equal to our base. Well, DE is equal to 25, and our base is equal to 3x plus 2. All right, and we already have our 2 times there. So now we just have to solve our equation that we set it up. Setting up was the hard part. Solving should be easy now. So we just do 2 times 25, which gives us 50. So 2 times the midsegment equals the base. Now, for both sides, we're going to subtract 2 to solve this equation. This cancels out. We get 3x is equal to 48. Divide both sides by 3. We get x is equal to 16. Now, I always think it's a good idea to check, so let's see if that even worked. Well, 3 times 16, right? I'm just plugging in for x, plus 2 is equal to 48 plus 2, which is 50. If AB was 50, does that make sense? Well, yeah, because half of our base is 25, and we did it. All right, for our next problem, K is the midpoint of HJ and L is the midpoint of HG. Find the value of x. Well, if K is our midpoint over here, we know that HK is congruent to KJ, and if L is our midpoint here, we know HL is congruent to LG. All right, because this is right in the middle. Now to solve for x, we have to set up our equation properly. And what we have to remember is that 2 times our midsegment is going to be equal to our base. And in this case, our midsegment is KL. So 2 times our midsegment, which is KL, is going to be equal to our base, JG. Setting up is the hard part. Now, as long as you have that down, the rest should be pretty straightforward. To solve this now, we just plug in what KL and JG are. So 2 times KL, which is our midsegment, or 4x minus 12, is equal to JG, which is 7x minus 9. To solve this, you might remember this, we have to do the distributive property. So the 2 has to distribute both of those. You get 8x minus 24 is equal to 7x minus 9. To solve this, we subtract 7x from both sides, and we get x minus 24 is equal to negative 9. Now to keep solving, we're going to move their 24 over, so we're adding 24 to both sides. Whoops! This cancels, and let me just move this away for a second. Oop. And we get x is equal to 15. Okay, now we want to find the lengths of GJ and KL. To do that, we just plug in. So GJ, it's 7 times 15 minus 9. We're just plugging in for x. All right, we're just plugging in our x. And for KL, we're just going to plug in x again, so it's 4 times 15 minus 12. Well, 7 times 15 would be, let's see, 70, 105. So 105 minus 9, 96. All right. KL, 4 times 15, 16 minus 12 is 48. All right, so KL is equal to 48 and GJ is equal to 96. Does that make sense? Yeah, our midsegment is half the length of our base. Okay, for this problem, we know that in the figure below, AB is equal to 10, AC is equal to 12, and BC is equal to 4. So AB is equal to 10, AC is equal to 12, and BC is equal to 14. Those are our three things. Now what we also know is that these are our midsegments, okay? We know that DF is a midsegment because E is a midpoint. As you see, it's in the middle, and F is a midpoint. We know DE is a midsegment. Oh, wrong color. We know DE is a midsegment because E is a midpoint and D is a midpoint. These are both in the middle. And finally, we know DF is also a midsegment because D is a midpoint and F is a midpoint. And how do we know these were midpoints? Well, they're right in the middle. And these congruence marks tells us that they're in the middle. All right. Now, we want to find out what DE, DF, and FE are. Well, it's not as hard as you think. If you look at this, DE is our midsegment, and AC would be the base there. So DE would just be half our base, which is 6. All right? So D is just 6. FE is a midsegment, and its base is AB. And since AB is 10, it's just half that, which is 5. And DF is also a midsegment, and its base is BC, and so it's just half of that, of 14, which is just 7. So we got 5 over here and 7 over here. The final question, though, is what's the perimeter of DEF? Well, this triangle goes right here, DEF. All we have to do is add the sides, so 6 plus 5 plus 7. When we add those together, we get 18, and that would be the perimeter of DEF. All right. In ABC shown below, L is the midpoint of BC, so L is the midpoint, and these would be congruent. M is the midpoint of AB, all right, and these would be congruent. All right. And N is the midpoint of AC. All right. N is the midpoint of AC, and those would be congruent. Well, since these are all congruent, we know that these are all midsegments. M and N are midpoints, so that's a midsegment there. M and L, those are both midpoints, so if I connect those, that's another midsegment. And L and N are midpoints, so if I connect them, that's another midsegment. What we want to do is fill in the rest of what we know. We know MN is equal to 8, so MN, which is right here, that's equal to 8. ML is equal to 5. And LN, or NL, is equal to 6. We want to find the perimeter of ABC. To do that, we have to answer these three questions: the length of AB, BC, and AC. So AB, to find that out, well, ML, oh sorry, we're looking for AB. So AB is right over here. All right, that's our base. The midsegment would be this guy right here, NL, right? These are parallels. So these are together. So we know that the base is going to be twice the midsegment, so we know AB is 12. We also know here that BC, that's the base for MN, right over here. So this would be double that, which is 16. And AC, that's right over here. And this is its midsegment, so that will be double it, that's 10. So to find the perimeter of ABC, we just have to do 12 plus 16 plus 10. ABC, 12 plus 16 plus 10, those are our three sides, and that gives us 38. And that would be our perimeter. Alright guys, that's it. So remember, watch your Disney movies, they give you good character and they're really cute.